tangents this time. All right, so check it out. We're going to graph tangent and see what the graph of this looks like, and it would make sense if you thought, well, it's probably another wave. That would be logical, and of course you're wrong. But good try. Let's go over here. Tangent is sine over cosine or y over x. They're the same. Sine is y and cosine is x. And so you're going to want to keep that in mind as we go. At 0, what's sine, what's cosine, or what's y, what's x? At that point, do you agree that that's 1, 0? So what's y, what's x? 0 over 1, which is 0. So tangent at 0 is 0. Perfect. We could do pi over 3's and pi over 6's, but we're going to jump to pi over 4, all right? So at pi over 4 on the unit circle, isn't it root 2 over 2, root 2 over 2 for cosine and sine, or x and y? So what's tangent? 1. So at pi over 4, 1. Okay. Now here's where we're going to want to look at this. This is where we need to put on our thinking caps. It gets abstract. What about at pi over 2, which is 0, 1? What's y over x? Undefined. How do I graph undefined? Yeah, so do you remember this graph? Y equals x, or 1 over x, y equals x. 1 over x? What does it look like? You don't know? Okay. Anybody? Yes, it's this guy. It looks like this. Can x equal 0? Not so much. So students, when I teach this in Algebra 1, students don't get that. You just can't. So let's look at it this way. I can multiply x over. Do you agree this is the same equation, just a little different look? So tell me, can x equal 0? Why not? It doesn't. It's understandable here, but here, think about it. Yeah, there's no way 0 times anything is going to be 1. There's just no way. And can y equal 0? No. So the graph has these, I can't go here kind of things. X can't be 0, y can't be 0. It's important to understand that math people didn't just say, this looks pretty, let's graph it this way. And then think about it this way, as if x and y are both 1. That's possible, yeah? Okay. And this is the part that I'm going to talk about here. What happens if x gets really, really small? Let's look at it in both cases. If x is small, say 1/100, what's 1 over 100? 100, right? 1 divided by 100, it flips, it's 100. So you're telling me that when x is small, y has to get big. That makes sense here, too. If x is small, but their product needs to stay 1, then y would need to compensate by getting bigger. So they're kind of inversely related. If x gets small, y gets big, and so on. Yeah? That's the idea then here. I just told you that tangent is y over x. So would you look at what happens if I take the ratio of this blue side to this red side? At 45 degrees, isn't that equal to that, and so it's perfectly 1, right? What happens if I get closer to pi over 2? If I look at the ratio of this blue side to this red side, isn't that like 5 times as big? And so tangent's going to be even bigger. And what about in the extreme, really close to pi over 2, like here? I mean, if I look at this blue side to this little baby red side, isn't now the blue side like 10 times as big as that little red side? So as we get closer and closer to pi over 2, these ratios are opposite to adjacents just get bigger and bigger and bigger. And so you're going to have a vertical asymptote there. Again, not because the graph looks pretty, but because as you get closer and closer to pi over 2, you just get a huger and huger ratio, and it just grows extreme. the y side's 1,000,000 times as big, or 2,000,000 times as big. All right, cool. Well then, what about, and this, what about then the minute you jump over 3 pi over 4, or 3 over pi over 2? So now look at a triangle over here. Oops. When I draw a triangle over here, isn't it that same idea of the y side is way bigger than the adjacent side? So it's also a huge number. But what about the signs? Is this y positive or negative? This is positive, but now this is negative. So I'm getting huge numbers again, but now they're not positive anymore. Now they're huge negatives. So now it's the minute you jump over there, you're going to start to get huge negatives. And what about at 3 pi over 4? Here, that's negative root 2 over 2 and root 2 over 2. So at pi over 4, that's negative 1, yeah? Now it's starting to, the y and x are starting to be a little more closely related. So this is approaching negative infinity there. What about at pi? That's negative 1, 0. Y over x is zero, right? Y over x, 0 over negative 1 is doable. That's not undefined. 0 in the top is fine, it's 0. 0 in the bottom is not fine, it's undefined. Are we cool? So it's going to come up to this guy. And what do you reckon at 5 pi over 4? What is tangent? 1. 5 pi over 4 is like there. And what happens about at 3 pi over 2? Again, that's y over x. That's 0 over negative 1. Y over x is negative 1 over 0. 0 in the denominator. Uh-oh, that is undefined. So what do you reckon is going on graphically at 3 pi over 2? It's a vertical asymptote. And then at 7 pi over 4, that's here. Sign-wise, that's positive root 2 over 2, negative root 2 over 2. So it's 7 pi over 4, negative 1. And at 2 pi, 0. Look at the pattern. 0, 1, undefined. Negative 1, 0, 1, undefined, negative 1. Okay, so you've got back to 0. What do you reckon is going on down here then? Probably again approaching the asymptote. Would you write yourself a note here? Notice for tangent, a full curve has a period of what? Now for sine and cosine, a full wave is 2 pi. But for this, how long does it take to go through a full graph? Only pi. So for tangent, you actually go a full length in only pi. It's a different period for tangent. Are you tracking? Okay. So let's think about this in terms of cotangent, excuse me. Cotangent is a reciprocal of tangent, or we could also think of it as cosine over sine, or x over y. Okay, so looking at these points here, here's the point at 0. What's x over y? 1 over 0. Undefined. So this one is already starting at undefined. What do we get when we get an undefined? What's graphically going on? So this one, cotangent, actually has an asymptote at a different place because it has a different 0 denominator problem. Where sine is 0, we've got a problem. Okay, so what about at pi over 4? 1. Now that's good because that tells me that how it's going to approach infinity. As we get closer and closer to the asymptote, doesn't it feel like it's going to be positive? What about at pi over 2? 0. 3 pi over 4. There's tangent. What's the reciprocal of negative 1? What? What's the reciprocal of negative 1? Negative 1, right? We don't change the sign. It doesn't flip, change the sign. It's still just a flip. So negative 1. And what about at pi? That's undefined. So we have another asymptote at pi. And so it's approaching that asymptote. From the left, it goes to negative infinity. What about at 5 pi over 4, cotangent of pi, 5 pi over 4? Positive or negative? 1. It's positive 1. 3 pi over 2? 0. 7 pi over 4? Negative 1. 2 pi? Fine. So another graph. So are they the same shape? Yes. But tell me 2 ways that tangent and cotangent are different. One is that they have different what? Asymptotes. Their asymptotes are different. Why? It goes to the denominator. Tangent is sine over cosine. So it has asymptotes where cosine is 0. And that's at pi over 2 and 3 pi over 2, etc. Cotangent is cosine over sine. So it has asymptotes where sine is 0. And that's 0 and pi and 2 pi. You can also see that the curves bend the opposite way, right? I would prefer you really can think your way through this rather than try and commit it to memory. Do you have that down? Can I move on? Okay. Isn't that about negatives in here? Is this the next piece of the note? Okay, cool. All right. Would you graph y equals, to graph cosecant, we want to relate it to sine, okay? So would you graph sine theta, please? Just really light sketching it. Now, oh, would you please make it dotted? Okay, because the question isn't graph sine. The question is graph cosecant. So I don't want to make it look like what I'm about to graph is the actual correct graph. It's not. All right. And I think for the head of the order, go here. Will you, let's see how good you are. Let's go through the unit circle. What are the y values here as we go through the unit circle? What's the y value here? 0 here, 1/2 here, here. 1, and then back down, but still positive or now negative? Positive. That should get us started. Okay, cool. Now let's think about this a little bit. When we graph cosecant, we're taking the reciprocal of each of those values. So at 0, if I take the reciprocal, then instead of a normal 0, now 0 is in the denominator. Think of it, if you like, think of it like 0 over 1. Do you agree that's still 0? If I take the reciprocal of that, now it's undefined. So where sine is 0, cosecant is undefined, and so there will be a vertical asymptote. So here, I'm going to have a vertical asymptote. And where else will I have a vertical asymptote? Where else graphically is sine 0? Everywhere that sine crosses. So I'm going to have vertical asymptotes everywhere sine is 0. I can't get a cosecant point there because those are zeros in the denominator. All right. Let's go in here. What about at 30 degrees, so pi over 6? What's the sine is 1/2. What's cosecant? 2. So here it's 2. And this is, what's the cosecant of pi over 4? Remember the value? I know it's, we flip that, but then we clean it up. What is it cleaned up? Do you remember what it looks like? Root 2, excellent. Okay, so that's 1.4. And so here is about 1.4, it's in here. And root 3 over 2, that cleaned up is, 2 or 3 over 3, that's 1.2, I think. Okay, so that's about 1.2. What about the reciprocal of 1? 1. So at that point, they're equal to each other. It's its own reciprocal. So you can see then that it's coming in here. So we kind of need to fill in the gap over here. I guess that means we need to say, what would cosecant be here? What do you notice about the y? When this angle is really tiny, what do you know about the y? It's really small, like 100. What happens when you divide by a really small number? You get a really big number. So here, when sine is small, cosecant is huge. So this actually approaches a vertical asymptote and it gets really big. And then what do you reckon is going to happen, going back to the right side of pi over 2, what do you reckon is going to happen as we approach that asymptote? These are just like those, and so it'll happen just like this. It goes. So it kind of looks like a parabola, but parabolas continue to go wider and wider. These don't, they are fenced in. At the ends, they almost look vertical. All right, so now, let's talk what happens when you trip over pi. What do you know about the sine values after pi? What are all these y values? Negative. And does taking the reciprocal change the sign? No, so our cosecant values will also be negative. So what do you reckon it's going to look like over here between pi and 2 pi? Show me with your, yeah, looks just like that. So I always think this looks like wallpaper. If you were to not have the sine curve and you were to look at cosecant, it looks like this. Just over and over forever. Lots of asymptotes in there. Okay, cool. So with that in mind, let's go secant. Start by sketching y equals cosine dotted. What does y equals cosine dotted look like? Where does cosine start, quote unquote? It starts at the top, yeah? 1, middle, min, middle, max. Okay. Now, let's put in the vertical asymptotes. Secant has vertical asymptotes where what? Why did I put my asymptotes at 0, pi, and 2 pi here? Because that's where the sine curve was 0 across the axis. So where do you think we'll put them here? Pi over 2. And 3 pi over 2. And if you wanted to, I guess you could put one in negative pi over 2. That's kind of off my space. Okay. Now I kind of know the shape. The shape will be the same. How do I know if the cups are above or below? Yeah, where this guy is positive, cosine is positive, secant's positive, and where secant's cosine is negative, secant's negative. So here, in this region, will I have a cup opening up or a cup opening down? Well, cosine is positive here, so secant should be positive, so it should open up. Between pi over 2 and 3 pi over 2, cosine's negative. So when I take the reciprocal, I should get negatives and negatives. You follow? So when you go to graph secant and cosecant, you typically graph the sine or cosine curve and see where it's at the center line, and where at the center line, then that's where your asymptotes are. Wow, this is so much. We'll get to that in a second, I guess. Does this look like your notes? I just want to make sure my notes are matching your notes. Yes. Okay, cool. Okay, so when you go to graph a secant and cosecant function, a lot of the work, most of the work is graphing the sine or cosine function. You do all that cosine sine graphing, and then after that you say, all right, wherever the sine or cosine has a center line, that's vertical asymptotes. And then you draw the reciprocals by just matching the bumps top and bottom, all right? We talked a second ago about how period of tangent is the normal period is pi. So in tangent, if you change the period, then it's not like sine or cosine where we do 2 pi divided by the coefficient, which is what we do in sine or cosine. For tangent, it's pi over the coefficient. So for this problem, thankfully, it doesn't say graph it. It just says, what's the period? So what's the period? Well, when I say coefficient, do I mean the coefficient of x or the coefficient of the function? It's the x. And so in this case, a full tangent curve would go through pi over 3. Now, secant, it's the same as sine and cosine. It relates directly to the sine and cosine. So it's like sine and cosine. So if I said, what's a full period of this? Do I use 2 pi like sine and cosine, or do I use pi like tangent? 2 pi over, what is the coefficient here? Is it 3? It is 1/3. So what's the total period for this? 6 pi. It would be really stretched. All right. The tangent curve will have vertical asymptotes at the same angle measures as which other trig curve? Explain why. Ooh, that's a good one. Tangent is sine over cosine. So it has vertical asymptotes where? What? Where cosine is 0. What other function has cosine in the denominator? And therefore will have the same vertical asymptotes. Yeah. Secant also is cosine. So secant is the answer. Okay? All right. So, with that said, do we get out of here right now or in 5 minutes? Super. Okay. Let's go through just real quick. Tangent. Where are the asymptotes? Sine over cosine. Where cosine is 0. Where are the asymptotes? Pi over 2 and 3 pi over 2. And the curves go through 0. All right? Bending that way. If you took the opposite of tangent, then that means change all the y's to negative. So that would mean reflect this way. So what would negative tangent look like? It would still have the same asymptotes, but what would the curves look like? It would be reflected this way. Yeah? Which is tempting to think, oh, so now it's cotangent, but no, the asymptotes are not cotangent. Okay, cotangent is cosine over sine. So where are the asymptotes? 0 and pi. And if you like, you could say, I know it goes through the zeros here, but again, use pi over 4 if you're not sure, but the curve's been this way. A negative cotangent would have the same asymptote spot. Oops. But they would be reflected over, so like that. Yay? Okay. We have time to do number 10. What's number 10? I don't even have this in front of me. What is 10, please? Oh, well, how are you supposed to know what 10 is? I'm so glad she put that down because I almost didn't give you the homework. That would be disastrous. We don't want that. That'll happen at least once or twice this semester. I'll forget to give you the homework, and usually it involves me chasing you down the hall and you walking faster. It's quite fun. So now my problem right now is I don't know where your homework is. So I might actually be chasing you down the hall. Now panicking. No, there is some. Hey, dude, not even the chance of no homework gets you excited. What does it take to get you some life in you? Sleep? Oh, I found him. Yay! You're so happy. Yay, learning. Here's some learning for you. Here's some learning for you. What do you work a full-time job outside of school or something? Oh, yeah, that is a lot of work. Marching band alone. Okay. Now my stupidity, I don't know if we have time for 10 and 11, but maybe we can start 10. Would you factor me a 2 out, please? No, you're out of here. So I would start by sketching y equals negative sine 2x plus pi over 2, because once you have that, then you can do the asymptote idea where it crosses the center line. So what is the starting point? What is the starting point? Negative pi over 2. Okay? What is the period? Pi. So where will it end? If I start at negative pi over 2 and go to pi, or go pi away, it'll put me at pi over 2. Where's the center point then? What's halfway between negative pi over 2 and pi over 2? 0. And what will these points be at? Pi over 4. So let's go a pi over 4 scale. Oh, shoot. Oh, now you're killing it. This is going to go great. Okay? And it doesn't look like this. It's actually a negative center. That's a good start. Okay. Have a great weekend. Good luck if you're running tomorrow, or if you're doing something else tomorrow. Whatever. Just good luck. Have a nice day. You're welcome. I have 7th hour if you want to work on this and you